Hi, hello. Now welcome to another session on my trigonometry for beginners. Now in the last episode, we have enumerated the 6 trigonometric functions. Now, we have defined it specifically for sine, cosine, tangent, cosecant, secant, and cotangent. Now in this video, I would like to show an example of a special angle, namely that is 0, 30, 45 degrees, 60 degrees, and 90 degrees, and their corresponding values in the 6 trigonometric functions. Now ChatGPT has tabulated it for us. We have the angles in the first column, and the corresponding values of these angles in the 6 trigonometric functions. Okay. Now, in order for us to have an idea of what this table is and what are the values written in it, you might as well copy it and superimpose it to our previous lecture. Here we have our lecture, the 6 trigonometric function and its definition, and at the bottom I have copied successfully the table generated and for demonstration purposes, I want to show to you the values generated for the 6 trigonometric function if your angle is 30 degrees. Now, here we have a right triangle. Again, from our previous discussion, our theta here stands for the angle. So might as well write this as 30 degrees. Okay. Now, we assign one of the leg, the opposite side, to be 1. Might as well assign it as a unity. And the hypotenuse, that is longer, so let's try 2. Okay. Now, how about this other leg? Now, we can't assign it arbitrarily. We have to find it. Now, in order for us to find it, we have to consult our Pythagorean relation. Now, we have to find that is c squared equals a squared plus b squared. Now, if our b here is 1, well, and our c is 2, we can find the other leg which is adjacent to this angle. Now let's try to do that. Now c squared equals a squared plus b squared. Now our c is, we plug in the value, that's 2 squared, and we are trying to find the adjacent side which is a squared. So plus, what's our b? We assign it to be unity, which is 1. So that's simply 4 equals a squared plus 1, and our a square, yes, you guess it correctly, that's 3. Now for us to get the value of a, all we need to do is take the square root of both sides. So that's square root of 3. So that's it. We have the value of a as square root of 3, our b, that is simply 1, and our c, that is 2. All we need to do now is plug in these constants to the corresponding 6 trigonometric function. Like for example, our sine of theta, again our theta is 30 degrees, we plug that in, and our b, which is the opposite side, we assign that to be unity again, which is 1, so that's simply 1 over, this is the hypotenuse, so that's the square root of a squared plus b squared from Pythagorean theorem, and we know that the hypotenuse is, we assign it to have a value which is 2, so we write there 2, and we were successful in obtaining the first entry for the sine function, that is 1/2. Okay, now let's try the cosine function. Now the cosine function is where that's the adjacent over the hypotenuse, so our adjacent side, which is a, we have calculated that to be square root of 3, then might as well put square root of 3, and we divide it by the hypotenuse, and the hypotenuse, we all know that we assign it as 2, so that is square root of 3 over 2. See, you see how easy it is? We just supply the correct values corresponding to the constants. Now our tangent is an opposite side over the adjacent side, and our opposite side, we assign it as 1, b is assigned as unity, So that's 1 over. And we have calculated our a. Again, our a here is square root of 3. So just write square root of 3. And we are correct. It's 1 over square root of 3. Now, what is this square root of 3 over 3? Now, it's perfectly legal to multiply this value by square root of 3 over square root of 3. Why is that? Because as you see, this is just 1. So anything that we multiply to 1, it remains itself. So it's simply 1 over square root of 3. So that's legal. So we multiply it by 1 or square root of 3 over square root of 3. What's left in the numerator is 1 multiplied by square root of 3. That is square root of 3. And in the denominator, square root of 3 multiplied by square root of 3 is simply 3. And there we have it. Our value here is square root of 3 over 3 as generated by ChatGPT. Now, how about for the cotangent function? Okay, again, we supply cotangent of 30 degrees. And this is just, as I mentioned, we define it to be an adjacent side over the opposite side. Now, our adjacent side, that's given as a, the value of a, we have calculated it again. That's square root of 3 from our calculation. Now, what's the value of b? Now, our b is simply unity, which is 1. So, square root of 3 over 1 is simply square root of 3. And that's the answer for our cotangent function, that's square root of 3. Now, how about this? Now, there's a twist to this. Now, you have noticed that our tangent is simply b over a, and our cotangent is a over b. Therefore, we can say that our tangent theta is simply the reciprocal of our cotangent theta. Again, our tangent theta is b over a, and our cotangent is a over b. They are the reciprocal of each other. Might as well, we can also write cotangent theta to be a reciprocal of our tangent theta. And we can utilize that definition to find cotangent of 30 degrees. Simply because we have the value of tangent of 30 degrees. Okay. So, what's the value of our tangent 30 degrees? Is simply, what's the value of our tangent 30 degrees? That's 1 over square root of 3. And if you bring this up, it simply becomes square root of 3. Amazing. So, again, we have recovered the value here, which is square root of 3. Now, here, for the cosecant function, we have defined this to be the hypotenuse. Our hypotenuse, again, is 2. And our opposite side is simply 1. Therefore, our cosecant of 30 degrees, therefore our cosecant of 30 degrees is simply 2. And that's correct. Okay. And we can utilize the definition here that our cosecant theta is simply the reciprocal of our sine theta. So our cosecant of 30 degrees, we can now represent it as 1 over sine of 30 degrees. And let's try to see if that is correct. So 1 over, what's our sine 30 degrees? We have found out our sine 30 degrees is simply 1/2. 1 over 2. And if we bring this up, we recover the same thing. It's still 2, as written by ChatGPT. Now, for the final function, which is secant theta, we notice that this is defined to be the hypotenuse over the adjacent side. Again, our hypotenuse is 2. And our adjacent side, we have calculated it to be square root of 3. And that's correct. So we have 2 square root of 3. Now again, what is this other expression? Or 2 square root of 3 over 3. Then we have to multiply this by square root of 3 over square root of 3. And now the reason is quite obvious, because still that's 1. So we recover the same value, 2 over square root of 3. But this time, if we multiply 2 by square root of 3, it becomes 2 square root of 3. Divide by square root of 3 times square root of 3 is simply 3. So that's the value. Now here, we can also use the fact that secant theta is the reciprocal of cosine theta. So therefore, secant of 30 degrees is 1 over cosine of 30 degrees. And this is just 1 divided by, what's our cosine of 30 degrees? That is square root of 3 over 2. Square root of 3 over 2. If you bring this up, it becomes 2 over square root of 3. And again, that's the answer. It's 2 over square root of 3. And that's it. I have shown you how to obtain the corresponding value for the sixth trigonometric function if the angle is 30 degrees. Now in the next episode, we will have more of this. We will have more examples regarding the six trigonometric functions. For now, that's all, and thank you.